Welcome to the second part of this spring semester final exam review. And we left off on question 21. We were asked to graph this. And first of all, we got to go ahead and talk about a couple of items in regards to this. Starting point S was going to be at 5. So in this case, we're going to move everything over 5 first. Now, apart from that, we are going to have an oscillation point. Oscillation is going to be 2. And then from there, my amplitude is 3. Now this gets affected in the sense that now we have 2 plus 3. So we'll have a line at y equals 5. And then we'll also have a line at 2 minus 3. So we'll have a line also at negative 1. So y equals negative 1. So we're going to draw both those lines as well. And that gives you an idea of how big it's going to grow. Now as far as the other components of it, let's talk about the frequency. The frequency has to do with the fact that this is a sine function. So remember, period is equal to 2 pi divided by the frequency. So which means that if I take 2 pi and divide it by the frequency, which is pi, I have a period of 2. And then from there, we're also going to go ahead and figure out, okay, tick marks, scaling. Last thing is the scaling part of it. And scaling involves taking the 2 that we have generated and dividing by 4. So we're going to do a tick marks by half in this case. Lovely. So we're pretty much all set up now to be able to graph this. Now, one of the things that we are going to do is that, remember, they want you to draw 2 cycles. Now, first of all, we are going to have a line that is y equals negative 1. So let's go ahead and kind of delineate that there. And then we'll also have another line which is 5. Now, something else that's going to occur. Well, let's draw a line in the middle, because this is kind of, I drew the axis, but in reality, you kind of want to modify this in the sense that we are talking about a sine function that's going to be symmetrical, but in this case, it's going to be pretty much right here at y equal to 2. And then from there, I will shift up and down by 3. Now, something important. One cycle will be hit at 2. That's the reason we have things at a half, because remember, this is a 1/2, 1, 1.5, 2. Now, we're going to have a total of, it wants to draw 2 cycles. So after that, this will be 2.5, 3, 3.5, and then 4. Now, after this, after we have all this, this is the most important part. I will be able to go ahead and now start my sine function. Remember, sine starts here. At 0, y is, well, actually, oh, no. Actually, take that back. At 0, when I'm thinking about 0 on the unit circle, y is actually, sine is 1. It reaches its altitude, when it reaches a half, it's going to follow this pattern here. So we'll have this kind of circle that gets formed, or the sine equation gets formed there. All right, lovely. Let's go ahead and move on to the next problem of this. Just do this one here. It says right here, 2 sides and an angle are given. Determine whether the given information results in 1 triangle, 2 triangles, 1 triangle, and all. Solve any triangles that may result. Now, this is going back to the law of sines. Now, in reviewing this, the biggest thing you want to do, step 1, is draw a triangle, and then just label your triangle. This is A, little a, known as alpha, in Greek terms, B, little b, known as beta, and C and little c, known as gamma. Now, let's go ahead and fill in the information that we do know already. We know that B, 17. Let's see, what else we know? A is 33. Angle is beta is 15. So when we have a side angle side, we have this idea that 1, 2, or no triangles can form at all. And what we must do is find out what the next angle is. So we're going to use the law of sines. Remember, the law of sines specifically states you're going to take the stuff that you do know, let's kind of do like a proportion, and we're going to cross multiply and divide. In this case, I'm going to use sine beta b, and then I'm also going to use sine alpha a And the unknown is going to be this, sine alpha. Because I know sine beta, sine 15 degrees, b is going to be 17. And in this case, we'll have sine alpha, the unknown, over a, which is going to be 33. Now remember, you cross multiply and divide. So let's cross multiply these two here. Now, one thing that's important to make sure your calculator is in degrees. Let's go to mode. It was in degrees, so let's switch that. And now figure out exactly what that will do for us. So let's do this. Sine 15 multiplied by 33 divided by 17, and we have this value. So we have this decimal value. So we're kind of left with this 0.500 equal to sine alpha. Now to figure out what alpha is, I got to take the sine inverse of this side and sine inverse of this. So I'm going to be exact, what I'm going to do in my calculator is that I'm going to go ahead and take the sine alpha of the answer, sine inverse of the answer. So I hit second, the negative symbol brings up my answer. Here you go. It's going to say it's about 30 degrees. So in this case, alpha is equal to 30.159, so 30.16. Oh, that's right, 30.16. Now this is important. And the reason being is that we have two triangles that might be formed. One of them off of the answer 30.16, and the other one the idea of its, well, I guess its predecessor, the subtraction of the value of them. So let's go ahead and first of all find out, can our answer have two triangles? So we're going to do this. We're going to go do 180 minus 30.16 to see if there's an alternate side on this inverse. Basically, we're going to be looking for the other side of this to see if there's another angle there. So let's go ahead and do 180. I'll go ahead. Before I do that, let me switch over to this mode. And I could type on here 180 minus 30.16. And there we go, 149.184. Now with that angle, 149.184, we have to now assume, okay, if I add, let's add the other angle, 15, can we have a second triangle? And it's possible. It's possible to have two triangles in this case because both these values are below 180. Remember, sometimes we have our other angle and it doesn't exist because it goes past 180. So in essence, we're doing this. We have to check. So when we check for the second triangle, okay, what did I do first? I did this answer, which was 149.84. So let's check for the second triangle. We have to add our previous answer, 15 degrees, add 149.84, and ask yourselves, is it less than 180 degrees? If there is, there could be a second triangle, in which in this case there is. So we're going to have to solve for the second triangle too, using this as an alternate, this being alpha 2, this being alpha 1. So let me get into it now. I'm going to take some additional space down here just because I need to. So let's go ahead and now figure out what the last one is. Because see, the thing is that we know what, we know what alpha is. We're going to go ahead and use that information to figure out what gamma is. And that's going to be done because remember, this is 30.16, right? We know by the definition of a triangle that they all have to add up to 180. So let's do this. 180 minus 30.16 minus, let's see the other thing, 15 degrees, the other angle, means that it could be 134.84. So this one could be 134.84. With that in mind, I could go ahead and use the law of sines now sine of 134.84. Use that with C. And then after that, we're going to go ahead and let's go ahead and use the same one, which we had sine of 15 degrees over 17. Cross, multiply, and divide. So, doing that, cross, multiply, and divide. Let's do sine of 134.84 multiplied by 17 divided by the sine of 15 degrees. Make sure I get that 5 there. Lovely. There we go. So that means that our C is really 46.57. So our possible C value, 46.57. Now this is just for triangle 1. This is with gamma 1. Now we have a gamma 2 that we said can occur. So I'm going to draw another triangle and go ahead and talk about gamma 2. Gamma 2, this is 15 degrees. I'll put everything pretty much in the same place. This was 17. This was 33. Gamma 2 we said could be 149.84. This is gamma 2. Not gamma 2, alpha 2. Gamma 2 means that we're going to have a possible another value. Well, let's go ahead and see what it would be. Let's do 180 minus 149.84 minus 15. Here you go, 15.16. So we got 15.16 as well. We can come up with a new C because now we have this proportion. Sine of 15.16. C is equal to sine of 15 degrees over 17. Same thing, cross multiply and divide. So in this case, we're going to do sine of 15.16. Didn't do the point. The point is now done. Take that and multiply by 17 divided by sine of 15. 17.177. So that means an alternate measurement could also be 17.177. This is a possibility. So here's the two solutions in order to do what we're doing. Now, let's go ahead and move on to question 23. So I think somebody's at my door. Hold on. Continuing. Let's go ahead and do the calculator portions of this. Now, let me go ahead and erase all this. Remember, you always go back and see the work that I did. Now, this one, they want to use a calculator in radian mode to find the value of the expression rounded to two decimal places. So this is going to be fairly simple for you to do. Just got to make sure you got the right mode. Well, you know what? I think I'm writing on this. I'm going to clear the ink on this. Go to actually selection tool so I could type on this. Mode, radian. And let me move this. Don't want to do that. Just want to move it. Let's see if I could do that just slightly. There we go. Okay. Quit there. Lift this a little bit more. Let's find the cosine inverse of negative 0.9. There we go. Round and just round to whatever it says to do. So there's one of them. Two decimal places. So in this case, 2.69 will be one of my answers. See if I can move this a bit so I could. Oh, there we go. Bring that down. And write down our answer. Let's do the other one. I know you all must be loving these because these are fairly simple to do as far as what's being required. Second sine, 0.6. So 0.64 in this case. So the next one would be 0.64. Now let's go ahead and move on to these other ones. Question 25. Now we have, with this one, you have to go ahead and bring out your green, I think it was a green sheet. So it has some formulas on these because you were not really expecting to memorize them. It was just to find the difference in certain angles. We had formulas. So let me go ahead and actually grab the formula and tell you what they were. Okay, the first formula, the formula that's derived off this is just this. Cosine is actually equal to cosine alpha times cosine beta plus sine alpha times sine beta. Now you might be wondering, well, what is going on here? I only have sine alpha, which is true. We do have sine alpha, but you don't have anything else. The thing is that this and this gives us two triangles, and where I could find out this, this, and this, those three unknowns. But I need to build the triangle, because one thing that's important with the right triangle in the unit circle, I could use my good friend Sakatoa, and this mate will be this tool will be lovely in solving answers. Now let's solve it. One of them says it's in quadrant 2. So quadrant 2, it's like this on the unit circle. And we must keep in mind that this is opposite. This is adjacent. Oh, I'm sorry. No, not opposite. No, oh, I'm sorry. That is opposite. The thing that needs to be corrected off this, yes, because I wrote down adjacent, is that that's really hypotenuse. That's important. You might be wondering why. Well, when my right triangle gets formed in my unit in quadrant 2, this is 13 and this is 5. Now I can use Pythagorean Theorem to figure out the x value in this. So we'll have a squared plus 5 squared 169 is equal to a squared plus 25. I solve for a squared, so I subtract 25 to both sides, and I'll end up with that a squared. Let me add some space here. It's really equal to 144 equal to a squared, which means if you take the square root of it, a is plus or minus 12. Now, here's your answers. You need to select one. The one I'll be selecting will be the negative 12. Why? Because that is the one that needs to correspond in this case. Now, why is this important now? Well, let me go ahead and circle what I just developed. This is important because now I could go ahead, you know how it asks me for cosine alpha? Well, cosine alpha is really negative 12 over 13. And that's the other part that's going to go right in here. So I have this now. Lovely. I have to figure out the other two. Now, I could do it, though. Why? Because I have this here. Now, quadrant 1, let's draw quadrant 1. Quadrant 1, if I draw a right triangle for quadrant 1, states that, remember, this is opposite over adjacent, which means that in our case, this is 3 and this is 4. This is a 3, 4, 5 triangle. So it makes it easy on this. If you don't know that's 3, 4, 5, feel free to do Pythagorean Theorem. You'll get 5 there. Cosine beta is really adjacent over hypotenuse, so it's going to be 4 over 5. And the other one is sine beta. It's opposite over adjacent. In this case, it will be 3 over 5. And I have all the values now to substitute into this equation. So now let's take our values and substitute them all. Negative 12 over 13 cosine beta 4 over 5 plus sine alpha. I think that's the only one I was given. 5 over 13. And I believe the other one's sine beta. Yeah, sine beta is 3 over 5. And let's simplify. This is going to become negative 48 over 13 times 5, which comes out being 5, 1, 65. So we'll have 65 there, plus 15 over 65, which means we get one solid fraction, which is going to be negative 48, plus 15, which comes out being negative 33 over 65. And there's your answer. So, solved. Lovely. Let's go ahead and move on to the next one. And let's see. This one says, given the sine alpha 8 is in 17, is in quadrant 3, it wants you to find sine 2 alpha, and it also wants you to find out cosine of 2 alpha. Now, this is also an application of an equation found in your green sheet. Let's do number 1. Sine 2 alpha has a trigonometric idea to it. 2 sine theta cosine theta. So we have that. And so that means we're going to, you can think about those as alpha, I believe. So let's go ahead and actually use let's come up with this idea on what it was like on quadrant 3. Now, quadrant 3 is going to be this quadrant here. So let me draw a little right triangle. This is, remember, this is opposite. Using SOHCAHTOA, this is opposite of our hypotenuse. Now, hypotenuse is always positive, so this will be 17. The opposite is going to be negative 8. Again, to use the Pythagorean Theorem, 17 squared is equal to a squared plus negative 8 squared. Develops an answer of a squared plus 64, 17 squared. Let's find out what that is. 289. Oh, it's not clicking over. Okay, there we go. So we have 289. Subtract 64, subtract 64. A squared is going to be equal to 225. Let's take the square root of 225. I'll say it's 15, but let's double check. Square root of 225. It is 15. So A is going to be plus or minus 15. Now, because of the location of the being in third quadrant 3, I'm forced to use negative. So this is really negative 15. Now, why is it important? It's important in the sense because now I know this is really 2 times negative 8 over 17. And cosine alpha, or cosine theta, which way you want to think about it, cosine alpha is going to be then adjacent. This is at theta or alpha, the way you want to think about it. It's going to be negative 15 over 17. So this will be negative 15 over 17. Like this, as such. So let's go ahead and multiply this fraction and see what we end up with as far as an answer. We're going to have, let's move this, negative 8 times negative 15 times 2. So 240, 17 times 17, 289. So let's math frac that. See what the reduction of that is. That's it, 240 over 289. That's the answer. Okay, we're going to do the same thing with the cosine theta. But just give me a second. Somebody's at the door. Let's continue. Now let's now do the other one, which is going to be cosine 2 theta. Nice thing is I have the triangle ready, so this number 2 will be, it's going to flow a little faster. 2 is going to ask you for cosine of the double angle of it, and this also has its formula. Its formula is going to be cosine. Well, actually, no, this one actually has more than one formula to it. I'll use this one, cosine squared theta minus sine squared theta. You're going to go ahead and take then my cosine value, which is negative 15 over 17 squared, and subtract that with the sine value of it, which was negative 8 over 17 squared. Let's see what answer comes out for us. Let's see, negative 15 divided by 17 squared minus negative 8. Negative did not go in there. Negative 8 divided by 17 squared. Let's get a fraction for this. 161 over 289. And there's your answer for that one. Lovely. Now let's go ahead and move on to polar and coordinates, and how to come up with the polar coordinates given a rectangular coordinates, how to convert it. If for those, remember, polar coordinate, it was a little different in where we had a r that signified like the strength or how far the ray went, and theta the angle of it. Now, two things that we must do. We must go ahead and actually, first of all, you want to plot the point. So if I was going to sit here and plot negative 8, 8, and it's going to be roughly somewhere over here, here. Now, why is that important? It's important in the sense because, first of all, it gives me an idea. Well, r, not so much, because remember, r, we're going to use the square root of negative 8 squared, and this is quadrant 2. Negative 8 squared plus 8 squared. And we're going to come up with an r value. So like in this case, it's going to be 64 plus 64. R is going to equal the square root of 128. You could go ahead and probably, you might be able to divide that actually by 16 and reduce that even some further. But the other part that I want to make sure I go over with you is on your formula sheet, whenever it's on the green or, okay, it's not on here. But what we want to achieve as well is the idea that to get you the angle theta, because to get you the angle theta, it's going to kind of be the inverse of what it is, but we're going to kind of reduce it in the sense, because see, we have the notion that it's negative 8, 8. So to figure out what this angle is here, or what the angle comes out being, we're going to go ahead and take like the tangent inverse of what it is of the function itself, but have to add things to it to get the right angle. Now, first of all, let's deal with r though. And okay, let's see if it divides. First of all, let's take 120. Ooh, writing on it. Let's clear that. Let's go back to actual writing. 128 divided by 16. It does. Okay, so that's actually going to be the value. And the reason why I'm doing that is because this is really the square root of 16 times the square root of 8, which means we have really 4 square root of 8. So that's really my r value itself. Now, as far as theta itself, we're going to go ahead and take the tangent inverse. Now, when it's in quadrant 2, remember, my tangent does not, will only give me values from here and here. So when it's in quadrant 2, you must add pi to it. Roughly, what does that mean? It means this. It means that you do, when you do the tangent inverse, let me get this in the right, okay. When you do the tangent inverse of the value of negative 8 divided by 8, you must add pi to this. And that's really what it's saying. So it's going to, when you add pi, oh, no. Let me do this, negative 0.78. You must add pi to get the exact value. Now, if you want the exact value, you could also look at your unit circle. And off your unit circle, you look to see when it's negative 1. Negative 1 only occurs at 3 pi divided by 4. So what you're going to do is write this down. 4 square root of 8, 3 pi divided by 4. Okay, good. Let me go ahead and pause this video.